Welcome back to this third video in our little series about binary. So the reason why binary is such a big deal is because virtually everything that's electronic these days is internally using binary. So even your calculator here, when you type into that 3 plus 7 and it throws you back the answer 10, and you're thinking, well, my calculator uses decimal, internally it's binary. When you hit the 3 button, it converts it to binary. When you add 7, it converts it to binary, it adds them together in binary, and then converts it back to 10 to throw it back out to you. So all computers are using binary internally, but a lot of the time you don't see that. So when you're looking at a spreadsheet on Microsoft Excel, it seems to you that everything's working in decimal. Behind the scenes it's working in binary. Now, to a lot of people that doesn't matter. They don't need to worry about the underlying binary. But once we start looking inside PLCs and seeing how they operate, and taking a look at how the memory is addressed and things like this, we're going to need to understand binary in order to get anywhere at all. If you've already watched the last 2 videos, you know how to work out conversion between binary and decimal. So the like of this here, you'll be able to work out what value that actually is. Remember, 1s, 2s, 4, 8, 16, etc., and just add up where you have the ones. Binary numbers are often written in this kind of format, which is groups of 4 or 8 or 16. So if we have the value 7, let's say, which is just 111, it'll often be written as this, where you've got 8 digits, 8 symbols, 1s, 2s, 4, 8, 16, 32, 64, 128, and 1, 2 and 4 are the only slots here that have a 1 in them. So 1 plus 2 plus 4 is 7 in our base 10, but often it's written with these leading zeros so that it makes up a group of 8. And sometimes it's actually written with a group of 16. So you may see binary numbers written as a group of 4, like this, or a group of 8 like this, or a group of 16. A single binary digit is called a bit. Binary digit bit. A group of 8 is called a byte, and you're familiar with that term from with normal computing, megabyte, gigabyte, talking about memory storage, and 16 of them is called a word. So those are 3 phrases that often come up in computing and working with PLCs: bit, byte and word. Bit's a single binary digit, byte a group of 8, word a group of 16. So within the computer, or in our case within a PLC, a binary number like this can be used in 2 different ways. So it can represent, quite simply, 1, 2, 3, 4, 5, 6, 7, 8 separate switches, completely unrelated to one another, where the 1 represents a switch that's closed, a 0 a switch that's opened, closed, closed, open, closed, open. So this can represent 8 things that are on or off. And when it moves from off to on, from a 0 to a 1, that represents the switch going from open to closed, something turning on. So a byte like this might represent a series of switches that are in various states. Each switch is either on or off. Or it might represent, as we looked at, an actual decimal value like 154. So this could represent 154 as in 154 degrees C in degrees centigrade inside an oven. So it could represent an actual quantity that you're more familiar with, or, as I say, a series of switches that are in a certain state.